Uh, Good afternoon, ladies and gentlemen. I am Aniket from EDS Technologies, and I will be your host for today's webinar. First of all, we thanks each and everyone for taking out time and joining this webinar. Without further delay, we will start with our webinar, streamlining product model comparison to save time and ensure documentation compliance. So now I would request Abhay to give a short brief about EDS Technologies corporate profile.
Thanks, Aniket. Good afternoon, everyone. Thanks for joining us today. Before handing it over to our technical speaker for the day, Sushil, I would like to give a brief introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and platinum partner to Dassault Systems. We have served more than 2,000 customers and operate across 11 locations in India with our headquarters at Bangalore. We also have various strategic partnerships with world leaders like EOS and Optomic for additive manufacturing requirements, human solutions for ergonomic solutions for automotive and aerospace industries, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with Mac Technologies, Echelon Technology, and Agenium for visual simulation solutions. We also have a strategic partnership uh, with Esri for GIS requirements, and with respect to EDA, we closely work with Synopsys. We have a dedicated sales, support, marketing, and customer satisfaction teams to address customers' PLM business and support requirements. The speaker for today's webinar is Mr. Sushil Punaskar. So, a small brief about Mr. Sushil. Sushil works as a senior solution consultant at EDS Technologies for specialized applications such as xCompare, Ramsys, QChecker, and Kava solutions. He has more than 20 years of industry experience working with major OEMs and major tier 1 suppliers as well. He has worked with major Indian suppliers as well as European OEMs. In addition to ergonomics, he specializes in BIW design and development, composites, and carbon fiber BIW design. Over to you, Sushil.
Thank you, Abhay, for the introduction of EDS and myself. So, good afternoon, everyone. Thanks for joining this webinar on xCompare application. So, we will see the necessity of xCompare application as such and where it fits into the total vehicle development scenario. So, we'll start and it will be followed by a subsequent short demo of the application as well in the end of the session. So we'll see the first and foremost is the need. We'll talk about the need of authoring the CAD design changes. What is the need? Why do we do this? And it's why it's critical in the whole design release scenario and total product development system. So as you know, releasing any design, we release the designs to meet the release gateways and design maturity demand that is put forward by a lot of cross-functional teams like manufacturing and assembly and simulations. So for that, we have to, as a designer, we have to keep extremely close watch on what's actually getting released into the system. That is our first and foremost kind of a critical activity that as a designer we have to do. Second thing, apart from these enlisted cross-functional teams like manufacturing, assembly, service, and packaging, regulatory demands, we have to agree with them all the changes in terms of geometrical changes or specification changes. And we know the changes are actually expected to be released apart from what is agreed with this many number of cross-functional teams. For example, any unwanted changes, if released by mistakes or inadvertently, then it will lead to a lot of release rejections. It will eat up a lot of your time, cost, and it will also create delays in your program because you have to release then again everything once more. There are quite a lot of chances that the supplier may implement the unwanted changes in tooling if that is not noticed, and that may lead to a lot of tool scrappages, which are kind of a very costly affair in the total development system. For that, as a one-liner, like designer, as a designer, we must keep a very close watch on what's actually getting released in the system, geometrically, in terms of specifications, in terms of CAD data, in every aspect. So for that, we usually do a kind of a overlaying of CAD to CAD and compare the things like what was in the previous release, what is in the new release, is everything exactly what we needed, all the changes are, we know what we're going to release. But it's a manual process, it takes time, and due to human error, it can also lead to a lot of errors also, because as a human being, we might something miss definitely while comparing the parts vis-a-vis. For drawings and annotations and CAD as a kind of final resource, we also do a lot of vis-a-vis comparison. We print out and we do a lot of comparison checks. But that is again a manual check. It leads to a lot of errors. So likely chances that due to manual comparing, some unwanted changes might get released, which is not really expected from the release. Many times it happens, and to rectify these changes, unwanted changes, we have to again do one more release next time where we remove these unwanted things and again release it. But it's again takes time and efforts. So let's see what comparing function actually is. Actually, it's not a very simple activity, though it looks very simple. So as just for out of our context, if there are two images quite similar looking, but there are many differences if we compare vis-a-vis, and if we are told to identify at least 10 differences in that, we have to look very closely, and in that process we will eat a lot of our time, and never sure we will be able to totally identify 10 differences. So it's quite unlikely. Similarly, for the engineering business or engineering scenarios, if at all, if there are two, it's again a body in white component, it's kind of a reinforcement. So, and it has a lot of GD&T annotations and callouts. So if we have to compare the annotations vis-a-vis over the two revisions, revision A and revision B, then technically it is not a possible thing, because if we overlay the GD&T callouts, then it will create a lot of chaotic condition. Nothing will be readable actually. And so comparing, overlaying the things, overlaying the GD&Ts or on each other is not a right solution, because it will lead to a lot of more errors. So as I said, comparing is really looks simple, but it's not a very simple activity altogether. Similarly, for example, in terms of extremely big drawing, you have many sheets of a drawing like NR, A, B, C, and etc. Sheet one of five, one of two of five, three of five. So if we compare just one revision NR, new release, and the revision A, and we are asked to compare view by view and etc., text by text, it is technically not possible. It is not impossible, but it will take a lot of time. And how much time is totally depends upon how much size of the drawing is. If it is a bigger and complex drawing, you will definitely need a lot of time in comparing the things. Similarly, for assemblies, though it's a similar looking up assemblies here, there are a lot of differences. If I have to just summarize the at least three of them, there are some missing geometries on the right side assembly. So certainly I have to spend again time. But how about if this function of comparing is the risk of comparing, if function is given to a kind of a automation tool or a kind of a solution where it very dynamically and very effectively compare the two geometries that can be part, drawings, assemblies, etc., and also the GD&Ts, and give a very dynamic report to you in a very ready-made fashion. That can be a very good solution. And xCompare is actually all about that function of dynamically comparing the geometrical and specifications of a product. Going forward, again, a kind of a bush here with a lot of GD&T callouts here. Again, we have a revision B with some changes. So if I have to compare, at least I will 5 to 10 minutes comparing it, callout by callouts, geometry by geometry. I have to overlay the things. But this is very simply done. And there, if I check, These are the four different areas that I have to very closely watch, and then I can figure out that yes, these areas are different, which will certainly take off some of my design time, which is actually a effective time for me to design the things. Checking is actually critical, it's important, but it consumes a lot of your time that is supposed to be spent on the design activities. There are typical scenarios like how xCompare can be useful for you in terms of 3D master. Like you can compare revision by revision of a CAD part, CAD drawing, or CAD assembly into CATIA environment. You can also face very confidently your design reviews and approval gateways. If you have a very ready-made kind of a very dynamic and effective report out of your what changes you have done with respect to the previous revision, you can very hassle-free you can pass the design reviews very confidently. Second thing, when you in the design team gives the data to the tooling team, then what care the tooling team should take. That is again we'll see in the subsequent slides. Whenever data is given from OEM to a supplier, we take a very high care in that, because everything that we deal with supplier is actually a cost and time. So we have to always ensure that we are giving right data, right revision of data with right amount of geometrical changes in it. Secondly, QChecker can also help you in the redesigning of parts, like you have some dump data that you want to remaster or remodel. Then you might have some CATIA V4 or legacy data that you want to remaster and in a parametric way. So QChecker can ensure you 100% geometrical compliances in that. And also, if you are giving data to the data some suppliers or third-party vendors, so you don't give any CATIA data. You always give some JT data, so that non-parametric data, which is and there can be a lot of errors that can happen in the translation. So these are some of the use cases where xCompare can very effectively support you in your total development system, and it can make your life easy actually with the help of xCompare. So as I said, xCompare is extremely fast and reliable solution. Will be followed for dynamically comparing and analyzing the data to two revision of data. It can be part, assembly, drawings. It is fully integrated in CATIA V5 and 3D Experience platform of Dassault systems. And it's a feature-based comparison that detects all design changes, including geometry and topology and annotations. That is FTA, we say that. In xCompare, we have around 50 checks available at the moment, catering to different areas like part, assembly, drawing. And some of the checks are like there can be some parameter that got changed, or some new parameter added, some old parameter got removed from the design, or some parameters got the name got changed. So all these changes actually have to be tracked as a designer. So QChecker can xCompare can help you in that. Then it can also help you in the GD&T callouts to understand the changes in the GD&T callouts between the two revisions. Tolerance values might get changed. Modifiers, that LMC, MMC modifiers may get added, removed. Mostly it get added. So that changes has to be very confidently known to the designer. Then it can also identify like if a sketch plane is moved, if there is a change in the input parameter, like a plane is there. If the plane position is changed, that can also lead to some of the errors. So it should be noted to the customer, but to the designer, yeah. So again, at the end of the xCompare, it gives a very detailed report at the end of the analysis, which can be a ready-made report for publishing to your cross-functional teams, and also face design reviews and approval gateway meetings with the help of that reports. It is a sample report given here, how the sample report looks like out of the xCompare application, where it is comparing two different versions, and there is a user interface of the xCompare that we will see in the subsequent slides. So some of the use cases, like how errors can happen when the data is concerned. So here this is a CATIA V5 data, and this area, this piece of this area here is actually getting troubled here when we create a JT out of it. So this piece of the surface is completely missed from the data. which is not a good scenario. So whenever you use this data to, or you release the data in this fashion, then definitely this data will not be accepted by your cross-functional teams like manufacturing or assembly or even the suppliers. So again, he will ask for the releases. So there can be some release demands again from the supplier that the data is incorrect. Yeah, these are the typical scenarios where this is a surprises we face in the release times. Again, it's again an example of the faulty tessellation, Jupyter tessellation data. So this is a final outcome, but there is a small surface popping out here, which is not a good scenario, and it has to be again released in the system as a data correction activity. Here, this slot here is actually due to translation in the JT. It has completely changed its shape, which is a completely faulty data. No one will accept this data. So it has to be released again. So if these changes are not noticed before the release, they can go completely unnoticed and get released. And the supplier may complain about the data quality. And nothing but we have to again release the data one more time without any reason. But that will take a lot of your time, efforts, and again you have to go through all the release and the change management process one more time, face all that people's scenarios and their troubles. So it's again a very cumbersome and troublesome activity. So with the xCompare application, you can really author your data quite nicely in that way. So as I said, in xCompare, you can really check version by version. xCompare can identify all the differences with respect to geometrical changes between the two revisions. It can identify the changes in parameter values, if any parameter added, deleted, or renamed. Then not only geometrical changes, but metadata like FTA callouts, tolerance modifiers, if they are changed or added or removed, or any annotations or callouts or feature control frames are modified or create or updated, or even in any datum targets are changed, like ABC or X1, X2, X3. These datum targets may also change due to some reason. Even that changes xCompare is possible to know very effectively before the release, of course. So we'll take a scenario like OEM to supplier scenario. So if a data is given to a supplier as a third-party vendor or a full service supplier, so for example, an IP supplier or cockpit supplier, so the data is given to the OEM, and the real job of the supplier is to identify the task of the supplier is to identify the changes between the current revision of the data and the new revision of the data, and he should have a clear idea of the components that are added by the OEM, they are deleted, or their position is moved in the reference data. So these all changes can be known very effectively with xCompare. Then he should also, by knowing this, he should estimate how does these changes affect his design activities. Is there any big design change, big change in the data? It's a smaller change. So that he can really make good estimate out of this if he uses xCompare to quickly bring him the change scenarios. As I said, with xCompare, products and parts comparison can be automated, and the verification is done very quickly in the on the go. So take an example of a tooling supplier. So OEMs give data to tooling suppliers. So they first give the block diagrams or block designs so that the material can be procured, the blocks can be procured. So the tooling maker activity or the what care he should take as a tool maker, that is there any identify the shape changes between the current revision of the data and the new revision, and verify that they are acceptable for manufacturing requirements. So he should know that yes, whatever agreed, that is only change in the design and no other things are changed. So he should be very careful, because based on this he will start his programming and machining planning, etc. So for that he has to be very careful with the data revision and what geometry has really received by him. So in case of any unagreed data, he should immediately inform back to the design team. So here with xCompare, he can really achieve a really high response time to the OEM. So within one day, he can really respond back to the OEM saying that the data you given is absolutely perfect, or the data you given is actually not according to our agreements. So this confidence really gains from the xCompare application. Otherwise, manually doing this is quite a hell lot of job. It will again eat your time. You can't really respond back to the OEM very quickly. So that is the trouble with the manual checking. But xCompare can resolve that quite nicely. Again, not very frequent, but there can be a lot of redesigning of the models due to the company internal standards got changed, or the company amalgamations or collaborations they club together or join together. So there can be some scenarios that parts has to be remodeled in certain way to meet the design standard of the company. In that way, xCompare can help you that in that way also to be 100% achieve the geometrical accuracies. Again, there can be some legacy designs to be remodeled into the parametric way. For example, the CATIA V4 data, or maybe any other dumb data you receive, and you want to make it to parametric. So by that, xCompare can really identify you between your more parametric design and the dumb design. It can really give you some areas that are not compliant. You can really make your designs compliant to that faulty areas. Again, when a company, it never happens very quite frequently, but it can change your native CAD platform also. Like Mercedes-Benz changed their from CATIA V5 to Siemens NX. They did a big data conversion activity many years back. So at that time, matching the data to 100% accuracy can be achieved with the help of xCompare. If any company is planning to do that, xCompare can be very helpful in that way also. Also, you might have some scan data and you want to make a parametric design out of it. And you have scan data as object and you want to model it as a parametric. So you can 100% achieve the geometrical accuracy according to the scan data. So, remastering of the part or drawings, for example, assemblies, we shall 100% adhere to the master data, that is the scan data. So doing this manually is not actually a right and very smart solution. It consumes a lot of time. So xCompare can help you in this scenario to achieve 100% geometrical accuracies and compliances. Yeah, as I said before, you can really have a very hassle-free design approvals going forward when you have some very interactive and dynamic reports like this, which you can print and you can take to the cross-functional meetings and design review meetings, and also attach this to your change notes in the design release process. And communicating, the biggest issue in design change approvals is the communicating the design is really a challenge. How to communicate what is changed is really a challenge in that the designer might face a lot of times. So for example, for design approval, often drawings and changes needs, these reports are demanded by a lot of teams. So to justify our designs, we have to many times make a lot of PPTs, a lot of bigger and bigger PPTs to support our change, which is again takes a lot of time to make those PPTs. But xCompare can help you this with the help of these small, very interactive reports that can help you with the design change documentation also. Yeah. So xCompare, as I said, it's available on. It can check your CATIA V5 to CATIA V5 parts, assemblies, drawings, products. It can also check CATIA V5 to CGR data, non-parametric graphics resolution, compact graphics resolution data. It can check that. You can check CATIA V5 to JT data also. So if there is any data given by supplier in terms of JT data, and you have a CATIA V5, so you can really compare vis-a-vis quite nicely. We'll see some examples like what are the typical checks and how xCompare can help you. So here's a sample. On the left side is a reference component that's you can consider revision A, or on the right side is a revision B. So if any change in the material also happens, from aluminum to iron, or maybe any other material change, xCompare can notice this change and it can give you a report of that, like the material has been changed, which is kind of a very good input to the designer that is it an intentional change or it's a by mistake it has been done like that. or even if you can identify that in previous revision there was aluminum and in the new release there is no metal applied, even that can also be checked with the help of QChecker automatically. It's again a good because no supplier will accept your design if there is a metal missing in that, metal specification is missing in that. It's a good, so such errors should be avoided, and xCompare can help in that quite nicely. Again, as I said, it's again same thing. It can pop up metal changes again. Yeah. In the part body, if there is difference in the areas or the total area or the volume of the component, that also can be noted with the help of xCompare. Yeah. If there is a CG due to geometrical changes, if there is a center of gravity shift between the two revisions, that also can be noticed. For example, it's just a small component, but take an example of a door shell or door structure. Uh, then the door hinge calculations are based on the center of gravity of the door system as such as a system. So any change in the center of gravity of the door shell will bring a lot of troubles. So knowing that what has any changes in the CG changes, it's good to keep watch on that. So xCompare can really you can really keep watch on how is the CG shifting in the assembly or on the part. Yeah, again, with a volume change, it can if there is a volume change in the two revisions, it can also check that also in xCompare. Here it's a there are two red sketches here, one red and one yellow. So xCompare has found out that the previous revisions it has the yellow sketch or the red sketch, and the new sketch is yellow. So it has automatically captured this check. When it compared the two revisions, it has found that these sketches are different. Though the name of the sketch is same, the geometry is different. So it is again a good practice and a good feedback to the designer that yes, is it an intentional change or it is kind of some under constraint value got changed and this sketch is updated accordingly. So we can classify that and go forward for our releases. Secondly, if any sketch is there and you change the center point or the start point or the reference point of the sketch, even that can be quite nicely captured in xCompare. You can there's the axis system that you always use when you do the sketches. So if that axis system driving point or the input point is changed, the whole sketch can change its location. So if there is any change in the input point, most possibly the sketch might also be moved from its position. So again, it's a intentional change or it's a by mistake that we can really author right in the digital way, so that these such type of glitches or errors should not get released in the system. Yeah, QChecker can also give you geometrical output in terms of what is changed and what is not changed. So you can really take out the surface data out of it, like what has really changed. You can transport or you can export it to your supplier also, that these are not agreed changes. So QChecker xCompare can give that confidence to you, like you can have a good control of your geometry, that what has really changed in the new revisions. Now here a clear scenario that the whole axis has moved upside, but we have to look very minutely if we are comparing manually. But in QChecker, it can really check very quickly that the axis of the hole has really shifted up. So the red area suggests that it has a new metal addition in the system or in the part. Again, not only geometrical, but it can like in GD&T callout also it can check. For example, it's if you look at the red mark here, this hole in the previous revision was 20 metric size 20, but in the new revision it is 22. Even that kind of changes also it can measure for you, so that we know that yes, is it an intentional change or it's a kind of a mistake. So again, to arrest the mistake, it's good to use xCompare dynamically. Yeah, so these are two versions overlaid each other. So if you see very closely here, these two versions are, fortunately, the position of the callout is not changed, but the text has changed, or the size has changed. QChecker can also help you if the callout's position has changed. If by mistake the designer move the position of the callout somewhere here, even that can be identified as an error. So technically, as a classical rule of drawing or annotations, we should not touch any dimension that is not changed. The value change are accepted, but the positional change are not accepted. So even that can be one of the good criteria to actually suggest our designs here. Secondly, as I said, there's a small tolerance shift here. I can say tolerance value has really shifted from 0.01 to 0.05 millimeter. So this also can be so callouts can also be checked in xCompare. So these are two overlaid again like previous image. Fortunately, the callout position has not changed. That's a good factor, but the value has got changed. Now again, from the designer side, we have to know that is it an intentional change or it's like a by mistake or a typo error, or maybe done due to wrong inputs. So such confidence is given. It's really you get a lot of confidence if you have this xCompare application with you. You can face such scenarios quite confidently. Again, here the total depth of the hole was previously 17.294, which has now go increased to 19.294. So 2 millimeter depth is more drilled here. Even barely looking, we will never be able to understand how deep the hole is. But QChecker can give you a good idea that the depth of the hole has been increased. Now again, it's an intentional change or it's an unintentional change that we have to classify and go ahead. Doing this manually is actually a cumbersome job, and bare eyes, we have to cut section here, draw overlay the another revision here, and then cut the section and then measure things. It's not a foolproof process. It's a traditional method of comparing, but xCompare can solve that complexity for you. Yeah, again here, not even the annotations or not even the geometrical changes, even the CATIA parameters values, as I said in the beginning, if the parameter name is changed or even the value is changed or any parameter is removed from the data, even those items are captured. Uh, so we have to again understand it's an intentional change or unintentional change, and then proceed for our design releases accordingly. As I said, here again, at the end of the session, at the end of the xCompare application, we have received two different type of reports, like a normal HTML report and a three-dimensional HTML reports. Where in this three-dimensional HTML report, you can really open it in any web browser, and you can zoom and rotate on this data right in the HTML, and it has a compare report directly here. So if you have to communicate your findings from comparing to maybe offshore team, so that when they come tomorrow morning in the Europe maybe or in Americas, and they get this report that yes, they will get quite nicely know that yes, the data given has these issues, and we have to rectify and give back to the India team. So this report will really help you in communicating your findings out of the compare. So for example, I have these three reports with me. Will try to open it one more here. Give me one time. So it will open again in the normal any web browser. It will open such HTML report. On the right side, on the left side, it will have what all red things are actually non-compliant. So between the previous revision and the new revision, these items are found not matching to each other. In this application, you can really zoom. Though it's a HTML, you can really uh, zoom it, pan it, rotate it, and see from different angles, and see from here the findings also. For example, if I see show properties here, or maybe timestamp or geometrical checks. For example, or maybe PMI checks if I see from the PMI checks. So, so these are the two regions. So clearly there is a difference here. It has found. So there's a tolerance change here. Like the previous tolerance, the new tolerance is the old tolerance was plus minus 0.2. The tolerance has been changed to plus minus 0.1. So again, it's an intentional change or it's an unintentional change that we have to classify, correct our designs accordingly, and then move forward. But this is all happened before your release of the design, not after the design. So QChecker can help you before the design release so that none of the wrong data is released into the system. So again here, material modifier, if you see here in the right side, right bottom side, the MMC modifier has been added, though other callouts are same. So it's again a good notice that yes, this MMC modifier, maybe some of the fixturing team might have, or the DVA team might have asked this modifier from your side, and hence you have added. But it's good to know that yes, this is according to the DVA team we have added, and we know this change. We are quite confident about this change, and we will release accordingly. So this confidence can really xCompare can give you in the beginning or before the release stage. Yeah, again here the tolerance has changed. Yeah. So these interactive reports and 3D HTML reports are available to you at the end of the xCompare application. I think we are at the end of the session. We are at the last slide, by the way. So with this, we will start our application here. The actual will demonstrate the xCompare application to you. We'll run for you a sample check and see how quickly and how effectively it gives a demonstration or the actual results to you, so that you are aware of all the changes between the two revisions. So I have this it's a, by the way, CATIA integrated application, so you need not have any, it's not available as a separate user interface. So it's identified by this X icon here. This is a normal CATIA v5 and it has this integrated xCompare application here. So I will just first load or load my two data here. So I have two data here of the mouse. Yeah, so the same component rather, the bush with the geometrical callouts here. So I have two revisions, one reference revision and one the next revision of it. So what I will do is once I have the data open, I will run this application from the toolbar here. It will give me a pop-up with some inputs to be given to the application. For example, this is a reference data. So you have to just pick the reference data from here. For example, the first one is a compare, so it's this one. And you have to choose compare means the new revision, the A revision or B revision. So once these two, the baseline design and the new design data has been pointed here, you can click this icon here where you can set its drawing. You have to select what type of component it is. It's a v5 part. So I will just click this. Then these are all the possible checks that you can apply while doing the check analysis. For example, the two areas, the application will compare the areas of the two revisions. It will check the axis system position of the two systems to the two revisions. Then it will also check the sketches of the two revisions. So likewise, like a metadata I said, annotation captures names, it will change. Annotation datum status, it will check between the two revisions. And there are ample of checks that by which you can certainly know that keep a very close watch on the data to be checked. So if I say okay here, and I say, and this is the where the data report will be stored. So if I show you the data report here, it will be a collection of lot of reports automatically captured in the after the end of the analysis. So you can run this. By the way, these are the same reports that I shown you minutes before. So we will run one demo run here. So it will take just small time to analyze. It's analyzing 2 revisions automatically. So once this analysis, what it's trying to do is completed, again a pop-up message, the result window will appear with a very dynamic user interface, wherein it will automatically align the 2 revisions in front of me, one with the reference and one with the compare, that's a new revision, and with the kind of a findings here. So it's a result window of the xCompare application. This is the only window applicable, available. There is no kind of a very detailed or very hard to understand user interface. It's very simple. So it gives me, if I select all, so it will give me a list of all things that it has checked between the 2 revisions. If I have to just check what are the equal things, we are of course not bothered about the equal things because they are anyway same between the 2 components or the 2 revisions. What we are more interested in the different and general error. So red marks indicate that in these areas there are certain differences in these 2 areas between the 2 revisions. So if I click areas, if I select here, it will give me difference between the reference area and the compare area, which is again good to know. It's not absolutely must to be known, but it's good to have because many times there is a limit on the weight also. So you can drive a property from here, from the area, you can calculate volume and have a property for the total weight of the assembly or the component in the CATIA. So if any area is changed, then that's a good part because the weight of the system or the part will go down. Secondly, if I go to annotations, so it has found that this linear size is actually changed. So it has highlighted me the linear change. So if I go again, and if I select this, so yeah, if I select this, there is a certain change in this. There's a value change between the tolerance change between the two. So you can identify the compare and the reference together. So it will bring that dynamically in front of you. If you see the tolerance has been changed again, 57 plus minus 2 and 57 plus minus 1 interactively again. You need not to browse through it. You need not zoom pan rotate to go to the change area. It will bring that in front of you dynamically. Again here the tolerance has changed. Yeah, these are the areas it has given a red and blue area, so it indicate that these are the geometrical changes between the two. So it can identify that also. You can also take out this as a kind of export function. These geometries can be exported out of the CATIA also. And it's the same function. It has compared two areas. So this is the thing it has compared here. So the nominal value has changed here. Likewise, this was one small example. Like we can take a lot of other examples also, but like drawings also can be checked, and genetic callouts also can be checked. Yeah. So I think that was a small webinar, but we would like to understand going forward if you would like to have a detailed webinar on your site about this xCompare application, so that we can check maybe we can take your two revisions and show you the how quickly it can compare, so that you get good confidence that yes, this application can be a good for your company, so that a lot of design time can be saved, and that design time can be effectively used for rest of the activities in the company. So I think that was it from my side, and the last but not the least was actually the report that we have to show you. It's again the same report that will open out what we have seen, again with the geometrical, which you can, this report you can share as a file also. It can open on any other browser anywhere in the world, and you can know that what are the differences in the data. Yeah, I think, yeah, so here the tolerance value has been changed. So again, we have to understand it's an intentional change or it's a unintentional change, and then move with our regular activities for the releases. I think that was it from our side about the application. Then I will switch over to my screen here. So we just finished our application here. I think that was interesting enough, though it was a short, but if you need any detailed application or detailed webinar or detailed demo at your company, you can contact us for such request, and we will demonstrate for you that. We can even take your two revisions and showcase that for you.
I would like to thank Mr. Sushil for delivering a very insightful webinar today, and I'm very confident it was very helpful for our audience today. I would also like to thank our audience for taking their time out and joining this session. So if you have any queries related to the subject matter or any requirement, you can always connect with us. Our details are displayed on the screen right now. You can reach out to us at any time and we would be happy to address your queries. Please do keep an eye on our upcoming seminars and webinars. You can follow us on our social media platform for the same. Sure. Thank you, everyone.